Hey everyone, Mr. Boykin here, Unit 9, Lesson 2, and this time we're going to be looking at the slope-intercept form of a line, y equals mx plus b, and we're going to be analyzing some points and given slopes or some graphs and forming that equation. Okay, so let's take a look right here at class example number 1. And remember that the slope of a line is going to be y, or the equation for a line is y equals mx plus b. M is the slope, b is the y-intercept. What do we know about the y-intercept? That is where x equals 0. So the information they give us is that there's a point, that's the x, and the y. So in this case, x is equal to 0. So if x is equal to 0, that tells me that 2 is going to be on the y line, which is the y-intercept. So the y-intercept is 2, and the slope right here is given to us is 5 over 2. So basically all you need to do is rewrite this as y equals 5 over 2 x plus 2. And that's it. Class example number 2, it says each line on this grid passes through some points with some coordinates. In each case, state the slope and y-intercept of the line and determine the equation. So you can see right here I've got line 1 and then I have line 2. So let's deal with line number 1 first. So what points can I find on this? Well, here's my y-intercept right there. So on line number 1, the y-intercept, which is equal to the b value, is going to be -4, and the slope, which is our m, is going to be equal to, well, I just need to find another point to go to. So here's another point right there, and now I want to figure out how far, what was the change in y? Well, I went down 2, so that'd be -2 over, and how far am I going over? 1, 2, 3, 4, 5, 6. So I'm going over 6 to get to that point. -2 over 6 can be simplified to -1 over 3. So that is going to be our slope for line number 1. And now we just need to substitute the m and the b with these values. So for line 1, y equals -1 over 3 x minus 4. And you could just input that on your calculator and graph it to verify if you've done that correctly. And let's move on to the next one, which is line number 2. And again, the first thing we want to do is find some points. Well, there is our y-intercept right there. So on line number 2, the y-intercept, which is equal to our b, is equal to 2. And our slope, which is the m, I just need to find another point. So again, I can go to, say, that point right there near the top that's crossing through the two lines, the horizontal and vertical lines, and I'm going up 1, 2, 3, 4, 5, 6. So I'm going up 6 units, and to the left 1, 2, 3, 4. So I'm going left 4, which is going to be negative. And I got a positive and a negative, so my slope is going to be negative. We're going to have to go back to line number 1. Hopefully you can see the mistake that I made right there. This is going to be reduced down to a slope of -3 over 2. Now, what you should notice is that if this line 2 is a negative slope, which it is, remember what we want to do is approach the line and then see once I hit it, does it go up or down? If it goes down, it's negative. Come from the left to the right and I hit this line, it's going up, so it should be positive, but notice that we put a negative slope here. And the problem was we did choose right here down 2, which is negative 2, and then it went left 6, which is going to be a negative 6, which means this would be a negative 1 over 3, and negative will create a positive, so the value should be 1 over 3. And so in here I just need to basically get rid of that negative sign right there. Okay, so now on line 2, I can finish this off with y equals negative 3 over 2x plus 2. And that is done. There's this one fixed up now, and that one right there. And let's move along. Just resize this really quickly. Put it over there. Okay, class example number 3. And on part A, it says we got a line that is parallel to the given line. What do we know about parallel lines? They share the same slope. And it says don't use this y-intercept of 4. The new line is going to have the same y-intercept as the other given line, which is negative 7. So this is as simple as just writing out the slope-intercept form and replacing the m with our parallel slope of 1 over 3x and the new y-intercept of negative 7. Part B says we've got a point passing through 0 and 9, and if I was to identify those as x and y, we know that if it has an x value of 0, that will be the y-intercept of our line. And what does it say right here? It's going to be perpendicular. So this is going to be important that we recognize it's perpendicular to a line that's going through these 2 points. So I need to calculate the slope of these 2 points right here and then apply the rules to make a perpendicular slope. So slope is going to equal the change in y over the change in x, which is going to equal y2, which I just need to label these out as xy1s and xy2s. So the y2 is going to be 0 minus the y1, negative 6, all over x2, which is negative 5, minus x1, which is 2. And we end up with a positive 6 over a negative 7, which is the same as negative 6 over 7, but that's of the other line. So our perpendicular one, we just need to apply the rules, which is we're going to take that to make it perpendicular. I'm going to take the fraction and sort of flip it, so it's going to become 7 over 6, and it was a negative, so it's now going to be positive. I change the sign. So our new the equation of this new line is going to be y equals 7 over 6x plus 9. Okay, and moving on to number 4. Question number 4 says the diagram shows the display for a graphing calculator. The intercepts are the integers, so we can see the points that they're going through. So we've got a point right down there, our x-intercept, and a point right up here that's going to be our y-intercept. So what we need to recognize right here is the scales. Okay, so whatever's on the x is going to be basically each little line or little dash right there is not going to be 1, a value of 1, it's going to be 5. So this becomes 5, 10, 15, and 20. Okay, so that point right there is going to be 20 in the x and 0 in the y. That's our x-intercept. And notice the y scale is 7. So basically it goes up 7, which means this would be 14. So this would have a coordinates of 0 in the x and 14 in the y. And it says determine the equation. Well, y equals mx plus b. We know b is the y-intercept, which is this point right up there. So it's going to be a 14. So I can take that b and replace it with a 14. Now what about the slope? Well, slope, How did I get from this point down here on the x-intercept up to the y-intercept? Well, I went up 14, so the change in y was going to be a positive 14, going this direction. And then I moved left, which would be negative. I moved 20. So it's a 14 over negative 20, a negative slope. And if I now reduce this fraction down, it should be 7 over 10. Okay, so the slope is going to be 7 over 10, and don't forget that it is a negative. Okay, so negative 7 over 10, and essentially I just replace that with the negative 7 over 10, and that is done. Okay, now it's asking us to take a look at horizontal and vertical lines. So again, think back to the theory that we had before. A horizontal line had a slope equal to 0, and a vertical line had a slope that was undefined, or it's not possible. Okay, now basically, if I look at, well, let's just run through this. State the slope and y-intercept of line 1. So line 1 is right here, which is this horizontal line, which is going from there to there. Okay, now it's at a value of y equals 4. And no matter what point I put on here, this is x of negative 5, y 4. This is x of 3, y 4. This is x of 8, y 4. Okay, so the slope of this one is going to be 0, and the y-intercept is going to be 4. And so basically when we substitute these values in, we're going to get y equals 0 times x plus 4. 0 times anything is just going to make 0, so we can get rid of that. So essentially we're just left with y equals 4. And if you punch in y equals 4 on your calculator, so y equals 4, and we graph that, we're just going to get a line going horizontally at 4. Now part C says let's take a look at line number 2. So again, it's just y equals negative 6. So if I went back into here and made another one at negative 6, it should be a line that's parallel to y equals 4, but crossing through the x-axis at negative 6. And there we see it right down here. Okay, so that part's pretty simple. Part D, state the slope and y-intercept of a vertical line, number 3. So that's going to be this one. Well, again, the slope is going to be undefined, so m is undefined, and the y-intercept is also going to, there is no y-intercept, so there is no y-intercept as well, it's also undefined. Okay, so what is going to be the equation for any vertical line? Well, just think back to what I said on the last one. No matter where I went on line 1, y was always equal to 4. Well, the same thing with this. No matter where I go on this vertical line right here, there's going to be one constant value in this, which is the x is going to be equal to negative 3. So in this case, x equals negative 3. And it says, take a look at, okay, well, I already got that, the equation for it. And basically, we cannot graph that on our calculator. Okay, so if you look at the calculator, it's asking for a function, y equals, but we cannot start off with an x equals right here. So we cannot graph that. But we can use the trace function and just keep hitting negative 3, and that will find that for us. All right, now using what we just learned right there, we go down to this class example 5. It says We've got a couple lines. They're passing through this point right here, -2 and 8. So what would be the equation of the line that is parallel to the y-axis? So at the y-axis, it's going up and down, which is going to be a vertical line, which is going to be x equals, well, in this case, the x value is -2. And the equation of a line parallel to the x-axis is going to be a horizontal line. So we're going to get y equals, in this case, 8. And that's it. We're moving on to the assignment.